This video is about continuity. So before I start with the how to determine if the function is continuous or not, we want to look at what are the why is it, how do you tell that the function is discontinuous or not continuous, right? So if you have a function given a function, there is a hole or a jump here, then that is a discontinuous. For example, an example of a whole is usually if you have a rational function. For example, if you have, let's say, x minus 4, x squared minus 4 over x plus 2, right? So that means that at x equal to minus 2, you can have that because you have 0 in the denominator. So therefore, if you simplify this problem out, you have x minus 2 times x plus 2, and that's divided by x plus 2. And you can cancel out x plus 2. And therefore, if you look at this equation, x minus 2, there is a continuous. But however, because this equation is simplified from this equation, so we say that there is a hole at x equal to 2, right? So that is an example of discontinuity, or it's simply a jump, like two different functions. For example, if you have piecewise functions, right? So function, right? So there's a jump. Or you have a vertical asymptote. So an example of that is if you have f of x is going to be equal to 1 over x, where at x equal to 0, you have a vertical asymptote. Yes. So at x equal to 0, you have a vertical asymptote. Right, so these are an example of discontinuity. That's you can graph your function now to see where the discontinuity, or if you were given a graph, you can tell that there is a discontinuity at these points right here. Okay, so how do we? What is the how do we determine that the function is continuous at some value x equal a? Right? So we have to satisfy three conditions. Where f of that value exists, the second condition is that we can find the limit of x approaches that value exists. And the third condition is that the limit of x approaches a equal to the value, right? So as an example, to test out how to determine whether the function continuous, so that we could test out this definitions here. Okay, so given this problem, f of x is equal to a piecewise function x plus 2, when x is less than or equal to 2, for x minus 2, when x is when x is greater than 2. All right, so how do we determine this problem here? So let's first check the first condition. The first condition is f of 2 exists, right? So that means that when x equal to 2, which means that we are going to look at this first equation here, x equal to 2, the f of x going to be equal to 2 plus 2, right? So we're looking for f of 2. F of 2, we're going to substitute x equal to 2 into first equation. First equation of f of x. Right? So that means that we have 2 plus 2 is equal to 4, right? So yes, yes, f of 2 exists. Okay, the second condition we want to test is the limit at x approaches a exist. which means the limit x approaches 2, does it exist, right? So I have drawn this out graphically here. You notice that there is a jump, so we know that between the two functions, there's the discontinue, but we're gonna see if we can prove that. 2 is the limit as x approaches 2 of f of x exists, right? So that means that the limit of x approaches 2 from the left-hand side of f of x equal to the limit of x approaches 2 from the right-hand side of f of x, right? So for the limit to exist at 2, the left-hand side limit had to be equal to the right-hand side limit. Now let's see if that is true, right? So by drawing this function out, you can try to draw this out. So this function right here is x plus 2. And this graph right here is 4 minus x. Okay, so let's say the limit of x approaches 2 from the left-hand side, then we're going to look at this graph right here, which means we're going to substitute 2 into the first equations. So limit of x approaches 2 from the left-hand side is going to be equal to 2 plus 2, which is equal to 4, right? Is it equal to limit of x approaches 2 from the right-hand side here? Right, which means the right-hand side, which means we're looking at this equation here, 4 minus x here. So we have 4 minus 2, which is equal to 2. So it's not equal. So that means the limit at x equal to 2 does not exist here. So that means that before I move on to the third condition, I can just conclude that this equation is discontinuous because the second condition does not satisfy, right? So we can say that this function is discontinuous here. So f of x is discontinuous. Continue because condition 2 is failed. Is not satisfied. Right? So that is an example of how you can tell continuous or discontinuous equations.